Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss electron spin. Let's begin. The Bohr-Sommerfeld atomic model gives the fine structure of hydrogen atom, but it has some kind of drawbacks. What are the drawbacks? Drawbacks of Bohr-Sommerfeld atomic model. It has two drawbacks. One is it could not be applied for the spectral lines of atoms other than hydrogen. That model is justified to determine or to explain the spectral line of atoms like hydrogen, but not hydrogen. Except hydrogen, it can't explain. And second drawback, this theory failed to explain anomalous Zeeman effect. What is anomalous Zeeman effect? When the light source was placed in an external magnetic field, when a light source is placed in an external magnetic field, the splitting of this light source means the splitting of that spectral lines into 4, 6 or more components. That is the anomalous Zeeman effect. Again I repeat, the splitting of atomic spectral lines into 4, 6 or more components when the light source was placed in an external magnetic field. That is the anomalous Zeeman effect. That effect cannot explained using Bohr-Sommerfeld. So, to overcome the drawbacks of Bohr-Sommerfeld atomic model, two scientists in 1925, one Gaudsmith and another Uhlenbeck, proposed new theory. According to them, what is that theory? An electron must be looked upon as a charged sphere spinning about its own axis. Spinning about its own axis. When it spins means it creates having an intrinsic means built in it, within that built, having an intrinsic angular momentum and consequently an intrinsic magnetic dipole moment okay. This is the proposal of Goudsmit and Uhlenbeck. An electron must be looked upon in a charged sphere spinning about its own axis. Look here, we consider that is the nucleus. An electron is revolving around that of nucleus, and that electron looked upon a charged sphere that spin with its own axis. It revolves around the nucleus, and at that moment it spins around its own axis. Due to that spin, two things developed inside it, that is, one is angular momentum. Due to the spin, the angular momentum is developed, and consequently a dipole moment, a magnetic dipole moment also developed within it. Again I repeat, when the electron is revolving around that nucleus, at that moment also it spins around its own axis. Due to this spin, two things created in itself, means one is angular momentum, and at same time magnetic dipole moment is created or built in it. So, there are called spin angular momentum. The angular momentum that created this is known as spin angular momentum. Spin angular momentum means due to spin the angular momentum created. So, the name is spin angular momentum, that is denoted by S, capital S vector, spin angular momentum. And due to that intrinsic magnetic dipole, created spin magnetic dipole moment, that created spin magnetic dipole moment, given as mu s vector. Due to angular momentum, it is named as spin angular momentum, denoted by S vector, and due to magnetic dipole moment, that is named as spin magnetic dipole moment, that created due to that spin and denoted by mu s vector. Now, the magnitude of spin angular momentum S is associated with spin quantum number small s. That spin angular momentum is associated with what? Spin quantum number. It is associated with spin quantum number, that is small s. Okay. As previously we discussed, the angular momentum L vector is associated with the orbital quantum number small l. In similar pattern, the spin angular momentum is associated with spin quantum number small s. Thus, what is that of magnitude? Therefore, the magnitude of that of spin angular momentum is associated with that of spin quantum number, means that is the S is given as, that is S whole into S plus 1 under root of H cross. Same pattern followed as in case of angular momentum, orbital angular momentum L vector, it will be L as small l whole into L plus 1, that is the orbital quantum number. Here S is half, the value of S is half, that is the spin quantum number for electron is half. Here for electron the spin S, sorry, the spin quantum number, that is the small s, is equal to half. Now the spin angular momentum will be, therefore the spin angular momentum capital S is equal to, putting the value as small half, sorry, half plus 1 under root H cross, that is root 3 by 2 H cross, the spin angular momentum. And its z component, the component of S vector means spin angular momentum along the magnetic field direction, that is the z component of that of spin angular momentum. Again its z component S z, that will be ms H cross. ms stands for spin magnetic quantum number. ms stands for what? Where ms stands for spin magnetic quantum number. Spin magnetic quantum number, ms H cross, that is the z component of that of spin angular momentum. And what is the taken values? The values takes it as 2s plus 1 values. Here the taken values is equal to 2s plus 1. In that of case 2s is half plus 1, means 2 values taken into consideration. One is plus half and another one is minus half. 2 values, one is plus s, that is plus s, and minus s, plus spin angular momentum and minus spin angular momentum. Here mu of s, that mu of s, spin magnetic dipole moment. So we consider for electron. So mu of s is equal to plus half and minus half, plus half and minus half, since it has 2 aligned values. And the z component, putting the m of s, that is that not mu of s, that is m of s, sorry, that is m of s, here m of s is equal to plus half and minus half. So s of z will be, plus h cross by 2 and S of Z will be minus H cross by 2. Okay. It has been concluded from the experimental data that the gyromagnetic ratio for electron spin is mu s divided by s, either twice of the gyromagnetic ratio for that of electron orbital motion, means mu l by l. Look here, from that of experiment, in experimental data, what achieve we? The spin magnetic moment is twice the gyromagnetic ratio. That is why we treat as mu of s as 2 times minus 2 E by 2m S vector, but we know previously mu of L is equal to not 2, that is only minus E by 2m of L vector. This is the twice, since the gyromagnetic ratio for electron spin is twice the gyromagnetic ratio of electron orbital motion. That is the basic difference why we use 2 here, and the negative sign indicates mu s and s are oppositely directed. Mu s and s are oppositely directed. Here, or that can be replaced as mu of s is equal to minus g of s E by 2m S vector, where g of s is called spin g factor, that value is equal to 2, where g of s is equal to 2, known as spin g factor. Now, the spin's magnetic moment, that is mu s is equal to minus g s E by m s, that is the spin magnetic moment can be expressed in terms of Bohr magneton. That can be written as, look here, in E by 2m I can substitute, that is mu b by h cross, that is minus g s mu b by h cross into s vector, and possible component of us along z axis further can be written like this. This is the mu s in terms of gyromagnetic ratio. In further, as us along z axis, just I write here, what is that experimental data, and it creates mu s along z axis, that is mu s z as minus g of s mu b by h cross s l is equal to minus g of s mu b by h cross in place of s l, that is ms h cross, that is s l, that is s z, the z component we consider ms s z. Here minus g s mu b by h cross cancel out, that means mu b into ms. Here we use Gs is equal to 2 and Ms is equal to plus half. Now using Gs is equal to 2, Ms is equal to plus minus half, we can write therefore mu s z, mu of s z component, mu s of z component will be plus minus mu of b component. Okay. The spinning electron concept proved to be successful to explain the fine structure of spectral lines and also for the anomalous Zeeman effect that can be understood by using the spin concept of electron. So, with the help of this visual lecture we understand what is electron spin. Spin angular momentum, spin magnetic dipole moment is exit from this and its denotation, its notation. What is the data? Finally, due to the discovery of electron spin, we can easily explain or we overcome the drawbacks of Bohr-Sommerfeld atomic model. That means the spectral line of atom other than hydrogen atom and the anomalous Zeeman effect can be easily explained by using this electron spin. So, with this useful and informative notes, let me wind up this session. Thank you.